Alright, so today we're doing chapter 7.1, problem 5. So the problem is, in the hammer throw, one of the earliest Olympic events, a heavy ball attached to a chain is swung several times in a circle as the athlete spins and then released. For 2016 Olympic champion Anita Wlodarczyk, the ball revolved in a circle of radius 2.1 meters and her final rotation took only 0.43 seconds. What was the frequency of this final rotation in revolutions per second? What was the speed of the ball? And what was the ball's acceleration? I'm just going to highlight a few things. So we know that 2.1 meters and 0.43 seconds are going to be important just because they're kind of the only numbers involved in this problem. And in the questions, we're trying to find frequency of the final rotation in revolutions per second. We're also trying to find speed of the ball and then the ball's acceleration. Alright, so on the next slide, what do we know? We know that her final turn took 0.43 seconds. Then we also know that the ball's radius, that includes her arms, was 2.1 meters. And then what do we want to know? We want to know what is the frequency of this rotation, what was the speed of the ball, and what was the ball's acceleration. To find the frequency, we're going to be using F equals 1 over T. So our time was 0.43 seconds. So F equals 0.43 seconds under 1. And then this is going to give us about 2.325. And then it wants it in revolutions per second. So that is our final answer for this part. And then moving on to find the speed of the ball, we're going to be using V equals 2 pi F times R. So I'm going to do 2 pi times 2.325. This is what we found in the previous problem. And then multiply that, 2.1. That was the radius of her arms and the ball. And this is going to give us 30.68 meters per second, rounded to about 31. Alright, so that's our final answer for this part. And then to find acceleration, we're going to be using A equals V squared divided by R. So we're going to be using 30.68 from our previous problem that we just solved. And then we're going to divide that by 2.1, which is again the radius. And this is going to give us about 448.37 meters per second squared. Alright, so our final answers are going to be 2.3 revolutions per second. Our speed is going to be 31 meters per second. And our acceleration is going to be 448.37 meters per second squared.